In this video, I'm going to be going over the the test 6 review. So let's go ahead and get started. So first of all, there's some properties of exponents that we have. We know that a to the 1 over n power is equal to the nth root of a, which specifically, the one we use the most is if you have some base to the 1/2 power, like a to the 1/2 power, that's equal to the square root of a. So anytime you have a square root, you can write that as that base to the 1/2 power. And then in more generally, a to the m over n power is equal to the nth root of a to the m. The key here is to notice that your denominator always tells you what root you're dealing with, and then the numerator, the m in this case, can either be put on the radicand inside the radical, or you can actually put it outside the radical. Alright, so let's go ahead and get started on number 1 here. You've got a 7th root of x cubed. So again, the denominator of our fraction is going to be 7, so it's going to be x to the 3/7 when we write it using rational exponents. When we see rational, think fraction. So on letter B, you should have, notice here your root is 3, so it's going to be to the 1/3 power. On number 2, this is a 4th root, and you can put x cubed inside, or you can just cube the whole radical. And of course, anything to the 1/2 power, that's a square root, so we get square root of x on letter D there. When it comes to negative exponents, we learned that negative exponents are a little deceptive. We don't get negative numbers out of these. We actually get reciprocals. So a to the negative n power is 1 over a to the positive n power. So for example, if you had 5 to the negative 2 power, that would be 1 over 25, or 1 over 5 squared, which is 1 over 25. So here we have 1 over 7 cubed. And when you multiply 3 sevens, you get 343. So let's look at letter B. If you haven't tried these, I would encourage you to try them all first and then check the answers on the video. So on number 16, this is going to be a square root since the denominator is 2. Now we could write the 2 in there right here, but we normally don't write the root when we're dealing with square roots. So it's the square root of 16, and then the numerator there is 3, so we're going to cube that radical. And now let's just take this step by step. The square root of 16 is 4, but we've got to cube that, so our final answer is going to be 64. Now, we learned when we have a fraction to a negative exponent, we can actually flip the fraction and change the exponent to a positive. So that's what we'll do here. And so we have 5 cubed over 2 cubed, and that's going to be, now be careful here, it's 5 times 5 times 5. You're going to get 125. 2 times 2 times 2, that's going to be 8. All right. So now on letter D, we're actually putting two ideas together, negative exponents and fractions as exponents. There's really 2 ways you could approach this problem. I tend to get rid of my negative exponents first, and so I could write this as 1 over 9 to the 1/2 power. But anything to the 1/2 power is a square root. The square root of 9 is 3, so we get 1/3. Now the other way you could have done this is you could have thought, let's put the negative 1 in the numerator, and so when we write it in radical form, it's going to be, because of the 2, it'll be a square root, and the numerator is negative 1, so it'll be to the negative 1 power. The main thing to watch out for here is you're never going to have a negative square root. Like I couldn't put the negative with the 2 because we don't do negative square roots or negative cube roots. Our root can't be a negative number. So in this case, the square root of 9 is 3, but don't forget your exponent is still negative 1, and then 3 to the negative 1 power is 1 over 3. Remember, if you know that 3 to the first power is 3, then 3 to the negative 1 power will be 1/3. All right, let's move on to the next slide. So again, I would encourage you to try these if you haven't already and see if you can get them on your own. Let's go ahead and look at this now. So on letter E, that negative is not part of your base. You're going to end up with a negative answer. Your base here is just the 27. So it's 27 that you're going to put under the radical symbol, and it's a cube root because our denominator is 3. And then again, don't forget that 2. We're going to square the whole thing. So again, you got to watch out for the negative there and knowing what your base is. Anyway, let's so we're going to get a negative answer because of that negative out front. The cube root of 27, well, 3 cubed is 27, so that would be 3. And again, we have the negative out front. Now, our base here is just the 3, and that's what we're squaring. And so we're going to get 9, and it's going to be negative, so negative 9. On letter F, you should have rewritten it like this. It's a cube root, but again, don't forget about that 2. You've got to square that. So we could think of this as the cube root of 8 over the cube root of 125. The cube root of 8 is 2, and the cube root of 125 is 5. So we're going to get 2/5. But don't forget we have to square that. So it's going to be 2 times 2 over 5 times 5. We get 4 over 25. So letter E, or no, E, F, G, let's see, letter G is going to be a 4th root of 81 over 16. Now, you can solve it just like that, or you can break it into 2, but either way, we have to find the 4th root of 81 and the 4th root of 16. It's not going to be a very big number. It turns out that 3 to the 4th power is 81, so the 4th root of 81 is 3, and 2 to the 4th power is 16, so the 4th root of 16 is 2. All right, let's look at number 4. So with this first one, we're going to use what we call the expanded power rule, and we're going to take 5 to the 3rd power, and we're going to take each of these numbers inside to the 3rd power. So 5 cubed is, well, we're just going to write it like that. X to the negative 2 power raised to the 3rd power, that's a power to a power, and so we want to multiply the exponents, we get negative 6. Y to the 4th power raised to the 3rd power, we'll multiply the exponents, and we get y to the 12th. So we know that 5 to the 3rd is 125, and we're going to need to move the x to the negative 6 down into the denominator, because remember that's equal to 1 over x to the positive 6. We learned that if you have a base with a negative exponent in the numerator, you just move it to the denominator and the exponent will change signs to become positive. Or if you have a negative exponent in the denominator, you can just move it to the numerator and make it positive. And then I just need to put my y to the 12th in there. So notice the only negative exponent was the negative 6, so that's the only term or the only variable that goes downstairs, the only part that does. Okay, let's look at B. So a to the negative 2, I want to move that downstairs. This is going to be 1 over a squared times b. And then anything to the 0 power is 1. So a over b, it doesn't matter what's inside the parentheses there. If you take it to the 0 power, you're going to get 1. And so this is just 1 over a squared b. All right, if you look at letter C, it's like doing like 3 or 4 problems in one. We've got the 5 over 10, that's a half. We're going to simplify inside the parentheses first because that's going to make it easier, and then we'll worry about the exponent. So x to the negative 3, I'm going to go ahead and, I could subtract my exponents. That's one way to do it. I'm just going to go ahead and move the x cubed downstairs with the x squared. And then y to the 4th over y to the 1st, 4 minus 1 is 3, so we're going to have y cubed. And notice the z there, it's just going to stay there. And that's all to the negative 2 power. So notice in the denominator we're going to have 2x to the 5th. I'm going to go ahead and flip the fraction and change the sign of the exponent. And again, I'm using 2x to the 5th there for my new numerator, which was my denominator. And now we need to square everything. 2 squared is 4. And x to the 5th squared, so power to a power will get x to the 10th. So we're basically going to take each of these to the second power. Y cubed squared, that's y to the 6th. And z squared is just z squared. Alright, so if you weren't able to get that one, now that we've done this one, I would encourage you to try letter D and then watch the video. Alright, so here again we'll simplify inside the parentheses. 6 divided 2 is 3. Let's go ahead and move that x to negative 3 downstairs with our x. And let's move the y to the negative 5 upstairs in the numerator with the y squared. And so we get 3y to the 7th in the numerator over x to the 4th in the denominator, and that's all cubed. So 3 cubed is 27. Y to the 7th to the 3rd power, that's a power to a power, so we'll multiply. And the same thing in the denominator, so we're going to get x to the 12th. Alright, let's move on to the next slide. Rewrite in logarithmic form. So one of the things we've talked about is how important it is for you to be able to go back and forth between exponential form and logarithmic form. So in these problems, they're all in exponential form. And I'm going to go ahead and write the first one up above. You've got to know your 3 parts. The 3 is your base, the 4 is your exponent, and the 81 I've been calling the answer. So those are our 3 parts. So when we change to log form, we've got to make sure we're putting each number in the right place. So I usually write log, and then our base is the little subscript, that would be 3 here. And then remember, the exponent always goes by itself, so that would be on the other side. And the answer goes right there. So it's base, exponent, answer. In this case, the 3 is your base, the 4 is your exponent, and the 81 is your exponent. Is your answer. So base, exponent, answer. And we talked about how you can check these doing, starting at 3 to the 4 power equals 81. I call it around the world. Let's go ahead and look at B here. So it's going to be a base 2 log, because our base, it's 2 to the negative 3 power. The 2 is your base. And then the 1/8 will go next, and the exponent goes all by itself on the other side. So again, to check it, it should be base of 2 to the negative 3 power equals 1/8, which is what we have up above. And so again, this is how you can check it. So here we have a base 10 log. The x will go here, and the exponent again goes by itself. And to check it, just go in reverse. It'd be 10 to the 3rd power equals x. Again, do around the world, and you get 10 cubed equals x. And that's how I check it. On letter D, we've got, I forgot on C. We need to write it without the 10, because common logs we don't write with the 10 shown. It's understood. Okay, letter D, it's going to be log base 5 of 30 is equal to x plus 2. Again, I can't stress how important it is that that exponent ends up by itself when you write your expression in log form. So again, you can check it. 5 to the x plus 2 power equals 30. Let's move on to the last one here. So this is a base E log, and that would be of 1 equals 0. Again, to check it, it would be e to the 0 power equals 1. And of course, we don't write log base e of 1. We write natural log of 1, which means our base is e. All right, let's move on to the next slide. All right, on number 6, now we're going the other direction. So 3 to the 5th power equals 243 is what we have here. On letter B, it'll be 6 to the negative 2 power equals 1 over 36. On letter C, we have 25 to the 1/2 power equals 5. On letter D, remember your base there is e. If you prefer, you can write it like I did here. And then e to the 2 power equals x. On letter E, again, here our base is 10. It's understood to be 10 since it's not written, and it's log. So 10 to the 5th power, to the 3rd power equals x plus 5, and that's that. All right, so now when we get to number 7, we're going to evaluate logs. Well, remember, a logarithm is an exponent. So when I look at letter A, I know that this expression represents, this logarithm represents an exponent. It's the exponent you put on a base of 4, that's our base, to get an answer of 64. What I usually do in my mind is this. I'm thinking 4 to the what power gives me 64, and that would be 3, so the answer here is 3. Now we could always check it. 4 to the 3rd power equals 64, and that's true. Let's move on to B. So I'm thinking 7 to the what power gives me 1/7? Well, you got to remember something about exponents here. We know 7 to the 1st power is 7, so that means 7 to the negative 1 power is 1 over 7. Again, negative exponents lead to reciprocals. So if we know 7 to the 1st power is 7, we know 7 to the negative 1 power is 1/7. And so that's negative 1, and so the answer here is negative 1. And when you check it, 7 to the negative 1 power does equal 1/7. On letter C, again, we're trying to think in our mind, what exponent do you put on a base of 3 to get 1 over 27? Well, we know that 3 cubed is 20. Whoops, I got ahead of myself there. We know that 3 cubed is 27. So that since it's a 1 over 27, the answer here is negative 3. On number 10 there, we know our base is 10. So we have to ask ourselves, what exponent do you put on a base of 10 to get 10 to the 5th power? This is just 5. So if you look at E, it's very similar to the one we just did. If we put in the E there, you can see that this is going to equal 4. It's just like letter D. Again, if it helps, you can write like I did here. The question is, what exponent do you put on a base of E to get e to the 4th power? That's just 4. And so we get 4 here. So on D and E, you can once you know the pattern there, you can just look at it and know what the answer is. But if it helps, you can show the work the way that I did. All right, let's look at letter F. So what exponent do you put on a base of 1/3 to get 27? Well, let's see. We know that 1/3 to the 3rd power would equal 1 over 27. So we're close. But this is where, if we recall, if we make that a negative 3, that would be 3 over 1 to the 3rd power, which gives us 27. So in any case, it's negative 3 that's going to work here. All right, let's move on to the next slide. All right, so on number A, or letter A, here we're going to evaluate these functions for given function values. What I always tell students is make a shell or a skeleton of the function. So wherever there was an x, now there's parentheses. And now we're just going to plug in 1. And so on the right side, we have to simplify that now. 6 to the 1 minus 3 power, that's 6 to the negative 2, which is 1 over 6 squared, or 1 over 36. On letter B, let's go ahead and make a skeleton. We're going to plug in 4. So we have negative 5 to the 6 minus 4 power. That's negative 5 to the second power. Now again, be careful here. Your base is just the 5. 5 squared is 25. So we're going to get 25 when we square that, but don't forget, we still have the negative out front. The negative is not part of the base. If it were, I would put negative 5 in parentheses, and we would have gotten a positive 25. So it's important that you only square the 5 here. So on letter C, again, we'll make a skeleton. And let's plug in negative 5. So we have 1/4 to the negative 5 plus 2 power. That's 1/4 to the negative 3 power. So we'll flip the fraction, and it becomes positive 3, and we get 64. On letter D, again, we'll do the same thing. We'll make a little shell here, plug in our 20. And in this case, you're going to need to use your calculator. So you should plug that into your calculator and make sure that you get the same answer I get here, which is 32,619. Now I put a lot of decimal places here. This is actually probably a formula in finance, so we would round to the nearest dollar and be money. But we didn't actually tell you that here, so I just gave you as many places as my calculator gave me. Let's look at number 9. So it's important for a lot of the problems we do, like when we solve equations, that you can put expressions like these into your calculator. So you should try these if you haven't already and make sure that you're getting the same answers I am. If not, you want to make sure you understand what you've done wrong and get that corrected. So on 9A here, you should put in second ln, and you'll see E, and then you'll see the caret symbol, and you'll put in negative 3, and you should get 0.0498. On letter B, you pretty much put it in like it is. Just make sure you put the 5 in parentheses, then divide by 0.03. You get 53.6479. On letter C, you're going to put it in like that, and you should get 1.7579. And then letter D, the main thing to watch out for this one, like the 5,000, you can just put next to parentheses. You'll do 1 plus 0.08 divide 4, end of parenthesis. But when you take the exponent here, you want to make sure that you put the 4 times 7 in parentheses, or you could just use 28 and not have to worry about the parentheses. In either case, you should get 8,705.1210. And by the way, you can see I'm rounding to 4 decimal places because that's what we were asking you to do. Right? 4, oops. Just be careful on the test. Make sure you're rounding as indicated on the test. All right, I'm going to go ahead and stop this video here.